Okay, recording is in progress. So let me share the screen. Okay, so we're just about done, folks. Welcome to December the 1st. So before you know it, we're all done and we'll be enjoying the holidays and all that kind of good stuff. So we have left the hyperbola and a quiz on Friday. Parametric equations are the last topic. Okay, so again, we'll set the exam as being on the 9th. Okay, so the 10th would just be an office hour. You can join or not. And the final exam again is Monday, the 13th. Okay, I'm required to tell you I have office hours the rest of the week, but it doesn't make sense, I guess, since the final exam would have already been finished. But if you want to meet during office hours, you're allowed to. It's not the same Zoom link, so let me know. Okay, so this coming exam on Thursday, the usual kind of exam, you have to submit the homework. You have to submit at least 70% of the homework. You'll join the Zoom session and so on. Okay, for reviewing for the final exam, go back over the previous exams. So I would say once the test is over on Thursday, then Friday, Saturday, and Sunday, go back and review the previous exams. I'm just thinking about that. So Friday, Saturday, Sunday, maybe do 2 a day. Maybe do 2 on Friday, 2 on Saturday, 2 Sunday. That's just a suggestion. You don't have to do what I say, but just in preparation for the test. But maybe go back and review exam 1 and 2 on Friday. The solutions video is always the day after, right? So Saturday, September 4th, look back on your Canvas announcements notes if you want the solutions video for exam 1. And for Saturday the 18th, it's always the day after, right? And then Saturday, the 9th, and Saturday the 6th. Maybe do that on Saturday the 11th, I guess. And then in preparation for the last 2 exams, that would be Saturday the 20th. Look at that video. And well, we haven't had exam 6 yet, but we will. I'll send a video on that for Friday the 10th. Okay, so a suggestion: do 2 a day. Maybe my suggestion, maybe test 1 and 2, review that on Friday, and then 3 and 4 on Saturday, and then Sunday 5 and 6, and then we take the final. Please again notice it's 8:10 to 10:40. That's school schedule. I cannot change that. So if you join our regular time of 9:10, I'll let you, but I have to stop at 10:40. Okay. There's no homework to submit for the final exam. You just take the final exam, submit it by 10:45, and then you're done with the course. Okay. The final exam will be questions primarily similar to previous exams. Okay, so what I'll likely do is I'll look at the first test and I'll say, okay, I like that question, that question, that question. And second test, I like that one, that one, that one, and so on. So assuming that's 3 times 6 is 18. So that'd be 18 questions, and maybe I have 2 more from somewhere else and go from there. You're allowed to have 6 cheat sheets. If you still have the formula sheet from the first test, second test, third test, fourth test, and fifth test, and you're about to have the 6th test, just bring it again. You say, I threw it away, I lost it. You can make it up again, I suppose. Okay. If you say, I wish I put that formula in, I wish I put that sample problem in, you can do it now. Okay. So let's say test number 4, right? Say, oh, I forgot to put blah, blah, blah on the cheat sheet. You're allowed to do it, go ahead and put it in now. All right. So that's how you would prepare for the final exam. And then we're done. We're done very soon, folks. Okay. It's less than 2 weeks. Today's December 1st. So December 13th, we're all done. Okay. Again, no promises on how soon I'll get you back your individual test 6. I may not even have it done for you by the time you take the final, since our final is so fast, but I'll get to it eventually, and you shouldn't concern about that because you want to study off the solutions video anyway. Right. So I'm going to try to finish by the weekend as I normally do, but just in case I can't, obviously when it gets to the final exams, I'm much more bombarded with things going on in preparation for grading and setting up final exams and all that. But don't worry, I'll get you everything you need eventually. You will eventually get your score on exam 6. You will eventually get your final exam score and your final grades and all that good stuff. That's for me to worry about, not for you to worry about. Okay. All right, so that's that. Now I will get started with some hyperbolas. Okay. So again, I changed the assignment to 1 to 25 odd. I'll show it to you again, but please notice there's a minus sign in standard form. Okay, so instead of having a minus, there's pluses. Okay. The designation for A and B is different than the ellipse. Okay. A will go with the positive and B with the negative. So in this particular case, A is 2 and B is 3. Okay. Right. If X is positive, Y is negative, I know it looks like this. If Y is positive and X is negative, it's going to go up and down. It's going to be the up and down type of hyperbola. So show you that again. So good one to look at and put on your cheat sheet is page 338. X squared over A squared minus Y squared over B squared equals 1. Okay, X positive, Y negative, left and right. Vertices. This one, Y squared over A squared minus X squared over B squared equals 1. Up and down. Okay, and I'll start showing you how to do that. You could make formulas for the asymptotes. I say don't do it, don't even bother with it. Okay, just do your rise over the run, and I'll show you what I mean. Okay, so today and tomorrow, I'll try to show you some hyperbolas. Well, here we go. So 6.4, page 342. Again, ignore any dates that are here. So X squared over 4 minus Y squared over 9 equals 1. All right, first thing I notice, X is positive, Y is negative. It's going to go left and right. So I like to draw myself a tiny little hyperbola here so I know what's going on. A is 2, square root of this number. B is 3, square root of this number. Okay. Again, for the ellipse, if this had been a plus, it's an ellipse, I would call this one A, I would call this one B. The larger number would be the A. Not for the hyperbola. The larger number goes with the positive, the smaller goes with a negative. Okay. And in some sense, as I said before, you can kind of think of that as still the larger number because this is positive, this is negative. A positive number is always bigger than a negative number, right? No matter what. So if you want to kind of follow that law, then say, okay, that's positive, that's still a negative, even though we're calling B3. For the hyperbola, A squared plus B squared equals C squared. Just like the old Pythagorean theorem. Again, you should feel fortunate that I'm not making you guys memorize this. The last time I taught the course face-to-face, you had to memorize this. Okay, my memory trick for this is hyperbola starts with a consonant. So consonant C stands alone. For the ellipse, which starts with an E, which is a vowel, A being a vowel is by itself. A squared equals B squared plus C squared for the ellipse. But that's moot point now because you get to write it on your cheat sheet. All right, so A squared plus B squared equals C squared. 4 plus 9 is C squared. C squared is 13. C is radical 13, which is about 3.6. So here we go. Center of the origin. When is it not center of the origin? Well, when you have this plus and minus stuff. Just like all the others. Parabola was like that. Ellipse was like that. Hyperbola was like that, right? Okay, left and right, I go 2. Up and down, I go 3. So if this had been an ellipse problem with a plus, I would just simply go like that. But it's a hyperbola. So for hyperbola, you take these 4 points, 1, 2, 3, 4, and you draw yourself a box. Like so. Connect the diagonals. They're going to be my asymptotes. Okay, vertices. Here are the two vertices, -2, 0, and 2, 0. Vertex 1, -2, 0. Vertex 2, 2, 0. Foci, this time the focus goes farther out than the vertex, which is the complete opposite of the ellipse. On the ellipse, the focus was smaller than the distance to the vertex, but for the hyperbola, it reverses. Okay. Vertex, distance, focal distance. Radical 13, 0, negative radical 13, 0. Focus 1, focus 2. Again, for all three shapes, the parabola, the ellipse, the hyperbola, if you look just at a small portion of the graph, it looks like the focus is on the inside of the curve, right? I mean, if I just looked at this, it's almost like you can't tell whether it's a parabola, ellipse, or hyperbola until you see more of the graph. Okay. All right, now, if y came first, y squared, x squared, I would pick these 2 points and curve it toward the asymptotes. But since I already know ahead of time, it's the horizontal type, x is positive, I take these 2 points and curve them toward the asymptote. It sort of tells me how wide or narrow the hyperbola gets. So there's my graph. Okay, so negative radical 13, 0. Again, write as exact values. When do I use the 3.6? Just to plot it. So I went 1, 2, 3, and a little bit more than half. 1, 2, 3, and a little bit more than half. Okay, how about the equation of the asymptotes? You can memorize a formula and all that. I say don't bother. Just look at this, over 2, up 3. Rise of the run, 3 halves. So y equals 3 halves x. This is automatically y equals negative 3 halves x. So that's the equation of the asymptotes. It's really, really close to the 2 asymptotes. So that's our basic first example of a hyperbola. Okay, number 3. Y squared over 4 minus x squared over 9 equals 1. Looks almost the same as this, except they switch around the x and the y. Okay, so here's the case where we are going to write y in the front. Again, for the ellipse, always put the x first and y second. Since, quote unquote, it doesn't matter, you should always write it the same way. X first, y second, even if this number was bigger than this number or vice versa. For the hyperbola, since subtraction is not commutative, it does matter. Y is first, x is second. That tells me it's going to go up and down. So I draw myself a little hyperbola. Okay. Remember when we were doing the parabolas, right? Sometimes I draw myself a little parabola that opens left, right, up or down, just to remind me, oh yeah, I see that this is squared in x, not in y, and positive, it's going to open up, right? Or if I see it's squared in y, but not x, and there's a negative, then I know it's going to open to the left, and so on, right? Because there were 4 different types of parabolas. There's only 2 different types of ellipses. It's either bulging horizontally or vertically. And there's only 2 different types of hyperbolas, either the left-right type or the up and down type. Okay, this one's going to be up and down type because I have y positive, x negative. So that is something like this. Page 340 for those of you with the text, right? Up and down type. See how it's y is positive, x is negative, right over here, right? Okay, so A is 2, B is 3, but have to watch out. A is a designation for 2. It's underneath the y. So up and down is 2. 1, 2, 1, 2. Left and right is 3 because this is still underneath the x. 1, 2, 3, 1, 2, 3. Draw myself a box. Connect the diagonals. These are my asymptotes. C is still radical 13. I mean, the algebra is exactly the same as this. Right. Since it's an up and down hyperbola, I take these 2 points, the 2 vertices, curve them toward the asymptotes. So here are the vertices, 1 vertex, 2 vertices. Vertex 1 is 0, 2. Vertex 2 is 0, negative 2. I already know radical 13 was about 3.6. So 1, 2, 3, a little bit more than half. Down 1, 2, 3, a little bit more than half. These are my foci, but write it as 0, comma, radical 13. and focus 2, 0, comma, negative radical 13. And now for the equation of the asymptotes, okay, don't memorize any formula, just look at rise over the run. Over 1, 2, 3, run 3, rise 2, rise over the run is 2/3, so y is 2/3 x. So the other one is automatically negative 2/3 x, because that's over 3, up 2. This is going to be over 3 and down 2, so the slope is negative 2/3. So y equals 2/3 x, y equals negative 2/3 x. And there we go. Okay. Okay, 5, x squared minus y squared equals 1. Even though they don't give it to you like that, I'm going to put over 1, right? X squared is the same as x squared over 1, right? Likewise, y squared over 1 equals 1. And x is positive, y is negative. It goes like this. Now, a side note, if this was a plus, x squared plus y squared equals 1, that's our famous unit circle, is it not? You would go 1 unit left, right, up, and down. But this is a hyperbola, okay? And it doesn't matter if this number is bigger than this number is smaller than this number, or they might even be equal. That doesn't change the fact it's still going to be a hyperbola. So a is the square root of 1 is 1. B square root of 1 is 1. A squared plus b squared equals c squared for the hyperbola. 1 squared is 1, 1 squared is 1, 1 plus 1 is 2. C is radical 2, which is about 1.4. All right, so from the center, which is the origin, 1 left, 1 right, 1 up, 1 down. So if this had been a plus, I would just go like that. But since it's a minus, instead I make a box, which in this case is a square. Connect the diagonals, which in this case you can tell it's easily y equals x, y equals negative x. Okay, if y were positive and x is negative, I would take that point and curve it toward the asymptotes. But since x is positive, y is negative, I know it's left and right. I take these 2 points, which are the 2 vertices, 1 vertex, 2 vertices, and just curve them toward the asymptotes. Okay, and what are the coordinates of the vertices? Vertex 1, negative 1, 0. Vertex 2, 1, 0. Foci, I go 1.4, 1 and almost a half, 1 and almost a half. Okay. So I need the 1.4 just to put the dot, but again, write the exact answer. So focus 1, negative radical 2, 0. Focus 2, positive radical 2, 0. Okay. So that's what we have here. Okay, now make it tougher. Completing a square. So stuff like 7 through 13. Okay, so I'll show you 13. If I show you 13, hopefully you can figure out the rest. And before going on, a little side note. Okay, so remember the focus is always on the inside of the curve. So here are the 4 parabolas, right? Opening up, down, right, and left. Okay. There's only one focus for the parabola, but there are 2 foci for the ellipse and the hyperbola. Okay. But in each case, if you look at just a small portion of the graph, right? If I only look at a small portion of the graph, like that, or like that, right? They all kind of look the same, where the focus is on the inside of the curve. Okay. For any of these, okay, take this one. If I only want to look at that part, it kind of looks like that, right? And it also kind of looks like that. So if you look for a very small portion of the graph, not a great big picture, right? After you take the whole graph, you look at it and say, oh yeah, that's a parabola, that's an ellipse, that's a hyperbola. But if you just take a very small section of each, right? Like if I just take a little bit right there, that kind of looks sort of like that. And that also kind of sort of looks like that, right? All right, so that was just extra. But that does tell you where the focus is. And the other thing for 13, we'll have to go back to our point slope form. Y minus y1 equals m times x minus x1. Okay, that's the point slope form of a line. We're going to be using that for 13. We didn't have to bother with that for problem 1, 3, or 5 because it was easy. You're centered at the origin. So when I do my y equals mx plus b, once I have the m, the b is 0. So I can go right away to, y equals 2/3 x and negative 2/3 x. But here, if the center is not the origin, then I have to rehash the y minus y1 equals m times x minus x1, the point slope form from algebra. Okay. If you need to, you can put that in your formula sheet, but theoretically, you already have it memorized once upon a time. Okay, so how do I complete the square? So I'll show you 13. And the others are going to be like it, 7, 9, 11, and so on, hopefully. Okay, move the 16 over. Put the y's together, the x's together, and factor out. So I factor out a 9. Don't take out the y, by the way, just a 9. So y squared minus 4y. Double check. That's 9y squared minus 36y. Yes, it is. Factor out a negative 4, x squared minus 4x. Double check, distribute back. Negative 4x squared. Negative 4 times negative 4x is 16x. And the minus 16, I brought it over here as 16. Now complete the square. Half the coefficient of y and square it. Half of negative 4 is negative 2. Negative 2 squared is 4. Plus 4, but writing plus 4 here in red is really plus 36 because of the distributive property of 9 times 4. Now this algebra is identical. Half of negative 4 is negative 2. Negative 2 squared is 4. So plus 4, but that's really minus 16. So minus 16 over here in green. Okay, so it looks like by taking inventory, we got everything. There's 9y squared minus 36y. There's minus 4x squared plus 16x. I moved the 16 over, that seems fair. I added 36, add 36. Subtract 16, subtract 16. Okay. So now that makes the right-hand side 36. This factors in a 9 times y minus 2 squared minus 4 times x minus 2 squared equals 36. The right-hand side isn't supposed to be 36, it's supposed to be 1, so divide by 36. So there we go. Y minus 2 squared over 4 minus x minus 2 squared over 9 equals 1. The center is 2, 2. Center is 2, 2. Y positive, x negative, it's going to be the up and down type of hyperbola. Okay, and for some reason, the author seems to like the same numbers, but A is 2, B is 3. We just did that. So C is still radical 13. The algebra is the exact same thing as all that, which is 3.6. Okay, so my center is 2, 2, right? A is 2, up and down 2. Vertex 1, 2, 4. Vertex 2, 2, 0. Left and right is 3. 1, 2, 3. 1, 2, 3. Draw my box. Connect the diagonals. They will be my asymptotes. Take the 2 vertices. Curve them toward the asymptotes. Here we go. Okay, what are the coordinates of the foci? Give exact answer, which means leave radicals as radicals and so on. So from here, I go up and down radical 13. The y coordinate was 2. So how do you take 2 and add radical 13? You literally just write 2 plus radical 13. That's all you can do. And here you just go 2 minus radical 13. That's considered the exact answer. Clumsy, but that's considered exact. Once you type it in your calculator, right, that's only a decimal approximation. It's no longer considered exact, right? So we want exact. That's the way you got to do it. Okay. Last thing is, how do I do the funny asymptotes? Well, for both of these two, you've got the same point, 2, 2. So y minus y1 is 2 equals m, x minus x1 is also 2. So automatically, I'm going to have y minus 2 equals something, x minus 2. So from the center, not the origin, the center, it's over 1, 2, 3, up 2. Slope is 2/3 and negative 2/3. So how do I write my asymptotes? Point slope form. Y minus y1 equals m times x minus x1. So y minus 2 equals 2/3 x minus 2. This is the exact same formula, except instead of positive 2/3, it's negative 2/3. But you still have y minus 2 because both lines go through the same point, right? Y minus 2 equals m, negative 2/3 x minus 2. And just stop there. Don't try to simplify that. Just leave it like that for the final answer. Okay. All right, so that was kind of complicated, but hopefully you can figure that one out. Let's see, depending on how much time I have, I might do another one like that, but I might save it for tomorrow too. Okay. Find the equation of the hyperbola that satisfies the stated conditions. Okay, so just come up with an equation of a hyperbola to do all this stuff over here. Okay, 15, foci plus or minus 5, 0. Vertices plus or minus 3, 0. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Focus 1, focus 2. Vertices plus or minus 3, 0. All right, so that tells me it is the horizontal type of hyperbola. So automatically, I know it's x squared over something minus y squared over something equals 1. And what are the somethings? Okay, so I need to find a b. It's basically 3, 4, 5, but I have a is 3. So how do you know a is 3? That's a distance from the center to either vertex is 3. By the way, how do I know our center of the origin? The center is halfway between the two vertices, or you can say halfway between the two foci. Halfway between negative 3, 0 and 3, 0 is the origin. Halfway between negative 5, 0 and 5, 0 is the origin. Best case scenario. Okay, a squared plus b squared equals c squared. A is 3, so a squared is 9. C is 5, so c squared is 25. Subtract b squared is 16, b is 4. So 4, 1, 2, 3, 4, 1, 2, 3, 4. Draw my box. Connect the diagonals. Okay. Rise over the run. 1, 2, 3 to the right. 1, 2, 3, 4 up. So y is 4/3 x. Y is negative 4/3 x. Should be a negative there. I'm not sure you can see it. And now the equation. X squared over a squared, x squared over 9, minus y squared over b squared, 16, is equal to 1. And there we go. Okay, 17. Vertices are 0 plus or minus 5. Sorry, foci 0 plus or minus 5. Vertices 0 plus or minus 4. Foci 0 plus or minus 5. Vertices 0 plus or minus 4. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4. So that tells me it's the vertical type, which automatically means y comes first. Y squared over something minus x squared over something equals 1. Okay. In this case, I'm not going to draw the rest of the problem because it only asks for the equation. So it only asks for the equation. That's all I'm going to give them. I'm not going to do the rest of the graph. C is 5. A is 4. Okay, we just did that. B is 3. It's 3, 4, 5. The algebra is exactly the same. Okay, so up and down was 4. That means 16 goes here. Left and right is 3. That means 9 goes here. That's all there is to it. The equation is y squared over 16 minus x squared over 9 is equal to 1. Okay. All right, and let's see. I think I was just going to show you one more. That's about it. Do I have time? Yeah, I think I give you one more completing the square type of problem, I guess. Go back and do number 11. 9x squared minus 4y squared, blah, 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 blah. Complete the square. Then I'll stop with this. So I'll be done in the next 5 minutes or so. Put these together and factor. So common factor is 9 times x squared minus 2x. Double check, distribute 9x squared minus 18x. Yep. Put these two together and factor out. -4, y squared plus 2y. Okay, so ignore the red and the green. 9x squared minus 18x minus 4y squared minus 8y equals 31. Complete the square. Half of -2, -1. -1 squared is 1. But by writing +1, it's really +9. Algebra is the same here. Half of 2 is 1. 1 squared is 1. In green, +1, but that +1 is really a -4. So the right-hand side now becomes 31 plus 9 minus 4. That happens to be 36. This factors in a 9 times x minus 1 squared minus 4 times y plus 1 squared equals 36. I want the right-hand side to be 1 divided by 36. X minus 1 squared over 4 minus y plus 1 squared over 9 equals 1. X positive, y negative. It goes left and right. The center is 1, -1. Translation of 1 to the right and 1 down. So center is 1, -1. And there's our old familiar friend. A is 2, B is 3, C is radical 13. We saw that before. It's the same math. Okay, so here we go. I messed up here. So let's see, the center was 1, -1. Left and right is 2, 1, 2, 1, 2. So this vertex 1 is -1, -1. Vertex 2 is 3, -1. Up and down, I go 3, 1, 2, 3, 1, 2, 3. Draw myself a box, connect the diagonals for my asymptotes. How do I write the foci? Well, 1 minus radical 13, -1. 1 plus radical 13, -1. That's the best you can do. And finally, how do I write the asymptotes? The center is at 1, -1. So automatically, I know it's going to be y minus a -1, y plus 1, equals blah, 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 x minus 1. And what are the slopes? Over 2, up 1, 2, 3. So the slope is 3 over 2 and -3 over 2. So my asymptotes are y plus 1 equals 3/2 x minus 1. And the exact same thing except a negative. Y plus 1 equals -3/2 x minus 1. And that's about it.
Is it okay if I follow the text way of writing the asymptotes of the equation, of finding the equation and all that?
If you go by formula and as long as you end up with this and this, that's fine. But I want you to just leave it like this if that's what you
It's
need.
a formula, but it doesn't end up like that. It ends up more like a y equals. It's not in point slope form.
Yeah, I want you to do point slope form. Again, it's to make things easier on me. Okay. Otherwise, I'd have to do all this algebra. It looks like it's a messy fraction.
Okay, well, the problem I have with it is that, like, you know, generally I look at an equation and I know where the y intercept is, and I mean, like, I could do the math. It's just really confusing for me. Like I don't know how wide to make the lines, or how deep or how, like, what's the word I'm looking for? Like, I don't know how wide to make the lines, and when otherwise I would know how wide to make the lines if it was like, if it wasn't in, if it was in a standard form, I think it's called.
You mean slope intercept, y equals mx plus b?
Yeah.
Okay, well, this way I don't have to find a b, first of all. I mean, that saves me a lot of time. I don't need the b, and I can get both equations fairly quickly. Okay, and I'm not bothering with making this look in y equals mx plus b form, because, you know, that's for algebra 1. We know how to do that. You know, these are completely identical except one's a plus and one's a minus. So bottom line is I want it to look like this. Okay.
Okay.
All right. Okay. Otherwise, I think I'm about done, folks. Let me stop the share and check if there's anything else here. Let me check the chat. Okay. All right. Any questions, please? Otherwise, we're done. Okay, folks, that's about it. So have a good day, and we'll see everybody next time. Okay. All right. Bye, everybody.
Bye. Thank you.